Good morning to everyone. I am Dr. Sumi MS. The name of the course is Electric Circuit Analysis and today's lecture topic is Kirchoff's laws. On completion, the students will be able to define Kirchoff's current law and understand Kirchoff's voltage law and solve problems applying both the laws. Kirchoff's first law, that is the Kirchoff's current law. The total current or charge entering a junction or node is exactly equal to the charge leaving the node, as it has no other place to go except to leave, as no charge is lost within the node. In other words, the algebraic sum of all currents entering and leaving a node must be equal to 0. So current exiting plus current entering is equal to 0. This idea is known as the conservation of charge. Here, current entering the node is given as equal to current leaving the node. I1 plus I2 plus I3 is equal to I4 plus I5, which is equal to 0. So I1, I2 and I3 are the currents entering the node, and I4 and I5 are the currents leaving the node. Here the three currents entering the nodes are all positive in value and the two currents leaving the nodes are all in negative in value. So we shall write I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. Kirchoff's second law, the voltage law. In any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop, which is also equal to 0. In other words, the algebraic sum of all voltages within the loop must be equal to 0. This idea is known as the conservation of energy. Starting at any point in the loop, continue in the same direction, noting the direction of all voltage drops either positive or negative and returning back to the same starting point. It is important to maintain the same direction either clockwise or anti-clockwise, or the final voltage sum will not be equal to 0. We can apply Kirchoff's voltage law for analyzing series circuits. Here in the circuit A, B, C, D, the sum of all the voltage drops around the loop is equal to 0. That is VAB plus VBC plus VCD plus VDA is equal to 0. Problem 1. Find the current flowing in the 40 ohm resistor. Across, here we have a 40 ohm resistor across the nodes A and B. The circuit has three branches, that is two nodes A and B and two independent loops. Applying Kirchoff's current law, the equations are written at node A and node B. I1 plus I2 is equal to I3, and I3 at node B it is I3 is equal to I1 plus I2. Using Kirchoff's voltage law, KVL, the equations are written as at loop 1 it's given as 10 is equal to R1 into I1 plus R3 into I3, that is equal to 10 I1 plus 40 I3. Loop 2 is given as 20 is equal to R2 I2 plus R3 I3, which is equal to 20 into I2 plus 40 into I3. And loop 3 is given as 10 minus 20, which is equal to 10 into I1 minus 20 into I2. As I3 is the sum of I1 plus I2, we can rewrite the equations as given here. 50 I1 plus 40 I2 is equal to 10 and 40 I1 plus 60 I2 is equal to 20. The above equations can be reduced to get the values of both I1 and I2 as minus 0.143 amperes and I2 is equal to plus 0.429 amperes. And as I3 is equal to I1 plus I2, we can get the value of I3, which is the current flowing across the resistance R3, as 0.286 amperes. And the voltage across this resistance R3 can be obtained as V is equal to IR, that is 0.286 into the resistance value 40, which is equal to 11.44 volts. Quiz questions on Kirchoff's laws. State Kirchoff's current law. What is Kirchoff's voltage law? Thank you.